So before going into this lesson, what are loops? What are loops? So loops are just basically things that happen over and over again. Instructions that repeating instructions. So when we talk about code in Scratch or in other block-based languages, we don't talk about lines, we talk about blocks of code. So you might have one block, and then you have another block that's a different color, and you might have another block that's a yellow block. So you have these three blocks, and together they might run when you say, when I click the green flag. So when you click the play button, you have these three blocks running. So the way that works is we have block number 1 here. This one runs, and then the second one runs, and then the third one runs. And that's how programming works. That's how languages work. They go from the top to the bottom, and once you reach the bottom, it's kind of over. And these blocks can do anything. Some of them, make a sprite move. Some of them make a sprite appear or disappear, show or hide. And sometimes some of these blocks make a character move up or down. And sometimes blocks do other things. And there are special blocks, and these are the blocks that we like to call loops. And that's what we're going to be talking about today. So for the next little bit, we're going to be going over, and we are going to be jumping into some code. So it's not all going to be just watching the screen here, but I wanted to kind of go over what it is because it's easier to show you here. So let's take a look at these three blocks that I have here. Okay, 1, 2, 3. We just take all of them. Okay, let's just move them outside for a second. So I'm going to write them out here again. 1, 2, and 3. There's a special block called the repeat block. And what that block does is it sends the flow of the program back. Instead of going this way, it goes back. So let's show you, let me write this down a better way. So let's say again we have three blocks. We have one, a green one, a yellow one, and let's say we've got a red one or a blue one, easy to see. And then here we have a fourth one. I'll make a pink one. So usually what happens is blocks go from the top to the bottom. So when the green flag is clicked, when we click the play button, we run this block, then we run this block, then we run this block, and then we run this block. But we have a special block, the one that's a little bit different. Let's say it's this blue one. I'm going to paint it with white stripes. We have a special block that stops this flow going down, and a block that sends it back up, sends the flow back up. Let's say it goes back up to green, and we have it start again. And this is called a loop. A loop stops the general flow of the direction that was moving. So we had the flow moving down, and it was going to go here from the blue block to the pink one, but this block stopped it. It stopped it because it said, hey, don't go down there, go up there. It could be any reason. We don't have to think about why it did that. It just did. It stopped it from going down to the red block, and it sent the direction back up until it goes to the green, and then we go down again, right? Then we go back here, and then it got to this blue block, and then it sent the direction back up again. So in this example, where anything that comes down to the blue block, it goes back up again. In this example, this red block over here will never be, the flow will never reach this block. So this block is kind of lonely because it'll never reach there. Why? Because this blue block is stopping all of the flow from going down there. So the computer program Scratch won't get to that block. And that is the concept that we want to show you today. It's the idea that a loop is sort of like the flow of your program. It's a flow. And it's a loop is a flow that starts from one end and gets back to the other end. Okay? So that's one thing that we want to get across. And now let's just talk about this in terms of code. So in simple terms, a loop allows us to repeat a set of instructions. So you can come to your Python code and you can follow along with me if you want to this part as well. So in Python, one of the primary, first, you know what, before we get into Python, let me go into an example here on what we mean by a loop. So let's say we have this cat over here, and I'm going to make this cat move 100 steps and then turn right 90 degrees. So over here is my cat, as you can see, and I'm going to make the cat. And for those of you that know Scratch, you can do this on your own. So for those of you that know Scratch, we're going to go ahead and make this cat go forward by 100 steps. So how do we do that? We go into motion, or the motion category. We click on the move block, and we're going to move the cat 100 steps. Okay, and there. So I moved it 100 steps. Keep moving it. There we go. I'll move her back, move it forward again. Okay, so that's cool. So whoops, didn't mean to do that. Next, what I'm going to do is do another thing. After I move the cat 100 steps, I'm going to turn 90 degrees. So I'm going to turn left 90 degrees. So here are my two blocks. I go forward 100 steps and then I turn 90 degrees. So let me click on that, and there we go. So I moved forward and the cat turned 90 degrees. I'm going to turn the screen darker so it's a little bit easier on your eyes. Okay, so here we go. I'm going to move forward and 90 degrees, move forward 90 degrees, and you can see what's happening. My cat is turning around in a circle because this is creating a loop. Well, it's creating a loop because I'm clicking it over and over again, but the concept is what we were talking about here. You start here and then you end up at the same place. Okay, so so we can move forward and turn right 90 degrees. Now, if I wanted to put this into a loop, this is not a loop yet. This is just doing it once. So if I wanted to turn it into a loop, I have to use a loop block. And the loop block in Scratch is called repeat. So don't worry about this. Is not a Scratch lesson. So I'm not going to go too much into this loop, into this block. But all this block does is that it repeats the statements inside here. It repeats the statements 4 times. So when I click on this, I get the cat moving around in a circle. Now that happened really quickly, so I'm going to add a little bit of a wait. I'm going to wait, let's say 0.5 seconds. So you could see it a little bit slowly. So here we go. And that's the cat moving. Let's do that one more time. 2, 3, 4. So this loop, this is a very typical example of what a loop is. So I'm gonna break this down for you. I'm gonna break it down for you. 1 second. Let's bring this in here because I really want you to get it. Okay, so we've got this Scratch block, right? What we're doing here is we're saying move 100 steps and turn 90 degrees, right? These are the two things. And then wait what this repeat block does is adds an arrow. So you can think of the direction of your program coming like this. Starts from the top, it always flows to the bottom, but then what this repeat block says is let's go all the way back to the top. Now because there's a 4 here, we do this 4 times. So I'm going to write 4 because it repeats 4 times, and that comes from over here. So that's what this program does. If there was anything after that, the blocks would continue only after these 3 blocks have been done. So the way that the computer works is it keeps a counter. So in the beginning, we'll start a counter. We'll start a counter here internally is equals to 0. Okay? And it says the counter is 0, and we're going to see if the counter is ever greater than 4. And 0 is not greater than 4, so we increase the counter by 1. We make the counter equals to 1, and we do these steps. We move 100, and then we turn 90 degrees, and we wait 1 second. Then we go back up to the top here. And then this counter runs again. This time counter is equals to 1, and 1 is still less than 4. We keep running over and over again. Eventually the counter will come to a point where it is 4, and 4 will not be less than 4. It'll be equal to 4, and then the flow will exit out. So that's how a loop works. You get into a loop, and there's always a condition. If there's no condition, then we will loop forever, and that's called an infinite loop. There's always a condition that breaks you out of the loop. Once you're out of the loop, you can go back to wherever you were. So that's how loops kind of work. This is the way that it's sort of designed in a design. And now let's go back into Python. And in Python, one of the primary loop commands is the for loop. And let's explore this using a practical example that you guys have all used before. It's probably our favorite Python language. It's called Turtle. And let's explore this using an example in Turtle. So we're going to use Turtle to illustrate a simple for loop by drawing a square. First, let's look at how we can draw a square without using a for loop. So in programming, sorry to keep switching to my sketchpad over and over again, but in programming, the thing that we're often doing is we're dealing with a problem. And we got to solve this problem. And what is the problem? Well, our problem right now, someone has given it to us, and they've told us we have to draw a square. So we need to draw a square, and what we have available to us is Turtle and Python. So there's many different ways we might draw a square. The first thing you might do is get your turtle, make your turtle go into this point, then have a command that pushes the turtle forward by 100 steps, then have a command to push the turtle turn to the right, have it go another 100 steps, have it turn to the right again, have it go 100 steps, have it turn to the right, and have it go 100 steps. So that is a problem. That is a solution to your problem. That is solution number 1, which I'm going to call the inefficient solution. So remember, we said that there's many different ways to solve the problem. So the first way might not be the best way. So let's call this the inefficient solution. Inefficient. So what we mean by that is it doesn't exactly, there's a little bit of waste. There's a little bit of, it doesn't make the best use of our resources. But let's draw out this. For some of you that already know Python, maybe you already know how to draw a square. But here's how I would go about doing it. In solution number 1 to problem, draw a square. And the solution is, solution number 1 is going to be, we're going to import Turtle. And we're going to say square is equals to turtle.turtle. And then we're going to use the square turtle to draw a square. So like we said over here, we're going to just go forward and turn right, forward and turn right. Forward and turn right, forward and turn right. So four times. So let's go ahead and do that. So square dot forward by 100, and then square dot left by 90, then square dot forward by 100, then square dot left by 90, then 2 more times square dot forward by 100 and square dot left by 90. How many have I done? 3. So 1 more. Square dot left dot forward by 100 and square dot left by 90. Okay, so let's run this script in your Python IDE or in Replit and observe how the turtle draws a square by moving forward and then turning 90 degrees and repeating this process. So if that was really quick, let me do that again. If you didn't see it, here we go. Let's run it. Okay, and I'm going to put the link to this example in the chat and in the description so you can use this if you want to use my example. And we all know how to draw a square now. So that was your solution. Hopefully that your solution is also matching up with mine. Now, while this does get the job done, it works, it's quite repetitive, isn't it? Let's break this down here. Let's take this code and put it over here. And here's the problem with this solution. Okay, even though it works, yeah, this works. It created the square by going forward. But here's the thing that I would point out right away if I was a teacher and you gave me this as your solution. Look what's going on here. These 2 lines are the same, and then these 2, and these 2, and these 2. So you're repeating these forward and left, forward and left, forward and left, forward and left 4 times. And that takes up a lot of lines. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that takes up 8 lines just to draw 1 square. Now, while that's good, you could do it better. So because you're a smart programmer, you're going to say, hey, can I draw the same square but using less than 8 lines? Can I do it in 6? Can I do it in 5? Can I do it in 4? And that's the challenge of being a developer. It's not about just creating something, but can you create it efficiently, making the most use of your resources? And we can. And that's where we use for loops. So remember what a loop is doing, right? It's oftentimes there's a condition, and it's saying something like if x is less than 10, then go here and do this, and if it's not, then go back. And it might be something like this. So this loop, this concept of the loop happening over and over again, you can tie that into this. So what we can do is, the first thing that you want to do when you notice a problem that can use loops is you want to see if there are things being repeated. So if you feel like there's a problem that can be, there's a code that can be made more efficient, the first thing you want to do is see if there is anything being repeated. And we noticed here that there is something being repeated, all of these. So what you want to do is you take out the thing that's being repeated. So what I saw here is I saw these 2 lines being repeated over and over again. So I'm going to take that out, and I'm going to put it over here. And then what I'm going to say is I'm going to count how many times they're repeated, and that's 4 times. So I'm going to put this in a loop. So I'm going to say, instead of doing this, put it like this. So repeat 4 times. Okay? This. Like that. So this is going to repeat 1, 2, 3, 4. In the end, it's going to do the same thing that this was doing. right? In the end, this and this is the same thing, except you can write it in a much smaller way. So you can repeat something 4 times. So every time you see a line that's being repeated, you take that line out and you just isolate the 2 lines. You look at them individually as their own and see if you can just repeat those things over and over again. And the way that we do that in Python is we find the 2 lines that are being repeated, and we find out, which is these ones here, we find out how many times they were being repeated. So we say 4 times. So what I'm going to do here is I'll say for I in range 4. Now these magic words and a colon at the end of it, what these magic words do is that they are the syntax, the words that we need to write to summon a for loop. Anything after this is going to be repeated. So the program is going to stop, and when it encounters a line like this, it's going to repeat the next indented lines. So indented means when I press enter, there is a space, there's a gap between the start of the line and where the beginning of the sentence is. That space means it's part of the loop. And what I'm going to do is I'm going to take those 2 lines that we copied earlier. Let me just make it was the t dot forward and t dot left, and I'm going to write them out here just once. So t dot forward by 100 and t dot left by 90. Okay, and that's it. So instead of t, my turtle is not called t, it's called square. So I just want to make sure that I have it square. And let's go ahead and run the code. And we could see we still get a square drawn on the screen. And instead, we only had 3 lines to use. So I'm going to take a picture of this and put it next to my old code and show you the difference in lines. Okay? So take a look at this. This was the code on the left, and the code on the right do exactly the same thing. But look how many lines you've saved. We can count it. You can already tell just by looking at it, but here we go. The old code, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now ignoring this top one, because that one I haven't added here, so I'll add this one. 1. Let's count. 2, 3, 4. So both the line 9 or 4. Obviously, if you can do something in 4 lines of code that you could do in 9 lines of code, then this is a much better solution. So they both are right? This one works and this one works. But this one, if you gave it to me on a quiz, I would give you better marks because you did it with a for loop and you saved all of this typing. Typing is what you're going to be doing a lot of. It's what I do most of my day, and anytime I can save my typing, it's much better for me. So, but the person that's looking at your code, that's looking at the design, is not going to be able to tell the difference, but you'll know, and that's all that matters. So that is the first part of this lesson, and then we're going to take a break right now. Let's take a 5-minute break. Now that you've learned a little bit about how to do for loops, we'll do some designs, and then we'll come back and do a little bit of that. So let's take a 5-minute break, recess, and then we'll return.